Hi everyone and welcome back to Fundamentals of Engineering with Farhad. Seismic Design. In this example, we have a frame example which handles a lateral seismic force at the top of one of its columns. So it consists of three columns, columns 1, column 2, and column 3. The 1 and 3 are identical to each other, fixed, and the second one is different in height and also 2EI versus EI, and also the fix and pin support. If we know that the column 1 and 3 are identical to each other, and we do know that the force F is equally distributed between all these three columns, we want to calculate the height of second column in the middle. So to approach our problem, as soon as the lateral force applies, the frame deflect like what you can see here. All the top supports convert to a sliding support. So they are like the side column convert to a fixed and a sliding condition, and the middle one is a pin and a sliding. So in our first solution, we have like if force F is equally distributed between all the columns, that we do know that the share of each of the columns is 1/3 of force, then you add them up is total F. And we do know that the status of these three columns due to this loading is in a parallel connection. So force and stiffness, force is directly related to the stiffness in parallel connection. So it just says if we want to calculate H2, stiffness of the second column to the total stiffness is equal to the share of the second column, which is 1/3 of the force, to the total force, which is 1/3 in the total. So if we have this relation, now we need to calculate the stiffness. So for a fixed and a sliding, K1 and K3 is equal to 12 EI over H cubed. H is equal replaced by 30 feet. And for the middle column, you can consider like a cantilever beam, which is like 3, the stiffness of that is 3 EI over L cubed. And for E, you just simply replace it by 2EI, which is provided in our problem statement. So K2 is equal to 6EI over H2 cubed. So if we replace that for K2, and on the denominator we have like this is K2 because we are looking for H2, and this is K total. That's 1/3. And if you simplify it and solve it for H2, it just gives you 23.8 feet. So in our problem, we were looking for H2 height of the middle columns due to this loading and this configuration of a structure, and it just gives us H sub 2 is equal to almost 24 feet. Thank you. We'll solve it in with a bit easier approach in next video. Thank you.